All right, mathletes, here's 4.5, properties of logarithms. So our goal here is to be able to work with logarithms, expand them, condense these logarithms. So our three main rules we're going to use here is our product rule. So if we have the product of two things of a logarithm, we can change this to addition. Okay, so then we also have our quotient. So if we have things being divided here, we can change it to subtraction when we include two logs here. Notice on this side, for these two at least, we have one log, and then on this side we have two when we change it from addition from multiplication and subtraction from division. So when it's m over n, we get m minus n. The bases of the logs stay the same as what you originated with. The last one is our power of a logarithms, that power of your logarithm can go ahead and be moved to the front, and you can change it to a product. So it's going to be k times the log of b of m. So how are we going to use these? So with some other properties here, we should understand that when we have anything when it's equal, when it's 1 here. Remember, if this is equal to x, then this is saying that 2 to the x is equal to 1. Well, anytime we have a power being equal to 1, this power needs to be equal to 0. So no matter what that base is, 3, 2, 3, 4, and it's equal to 1 there, or it's 1 there, then we know it's going to be equal to 0. Okay, using that same idea, if this is x, this is saying 2 to the x is equal to 2. Well, the way that you get anything equal to itself, you let the power be equal to 1. So this is equal to 1, 1, 1, when the base matches this. Okay, so this property, anytime you have a 1 here, your log is going to be equal to 0. Anytime that this matches this, it's going to be equal to 1. Well, ln of e, you can think of that as log base e, so this matches that, so that is equal to 1. So that can help when we're solving equations using logarithms. Okay, so some other properties here that we should note, so that if we have something with a power here, so we say this is x, remember this is the same thing as saying 3 to the x is equal to 3 squared. Well, then that must mean that x is equal to 2. So those powers are the same. So something like that there. So our property here is if this base is equal to that there, then we have it equal to x. So the other way around is that if we have 2 raised to the log base 2, it's just going to be equal to 1. It kind of undoes it. Power 2 with a base 2 of a log, that's going to cancel it out, and we get a 1. So we get a 2 here, we get a 4 there, and an 8 there. So a raised to the power log a to the x is just going to be equal to x. That 2 will help us solve equations with logarithms. All right, so let's use a couple of these properties to solve these out. So anytime we have this equal to 1, the logarithms equal to 0. Anytime that this is equal to itself, our logarithms equal to 1. And anytime that this is matching this, we're going to see that this is equal to 30. So another property here is if we have log of a to the x equals log of a to the y, well, then x has to equal y. So we can just get rid of our logarithms altogether. So remember, if it's not written, we assume that these are base 10 logarithms. Okay, so they're both the same base 10, so we just can say that 4 minus 3x is equal to x plus 2 and solve this out. So subtract x from both sides. And and then let's subtract 4 here, subtract 4 there, and I'm going to get negative 4x is equal to negative 2 divided by negative 4. And I get x is equal to 1 half. Okay, so let's go ahead and look at another example here. Example 3. So we're going to use our properties that we talked about, our power and quotient and multiplication properties, and expand these as factors. Okay, so I look for everything that's multiplication. So every term in theory is going to get its own logarithm base 4. So I can do log base 4 is 16 plus log base 4 x cubed plus log base 4 of y. Well, if we can ever simplify them and they're only just numbers, we want to. So this is saying 4 to what power is 16. So I know 4 squared is 16, so that's 2 plus. Now I'm going to use my power property, and I'm going to write that down as a factor. So I can do 3 times log base 4 to the x. And then this one can't be simplified anymore. Log base 4 to the y. So I've written this now as a sum and difference of logarithms. This is going to be useful in calculus when we're trying to break up things to integrate and differentiate so that we have sum and differences as opposed to multiplication. Okay, so B, we treat ln just like we can treat logs. So for this one, I'm going to use my power property first. So this is going to drop down in front. So I'm going to do 2 times ln of, and I'm going to rewrite the numerator as a power, 1/2 over 7. Okay, so before I separate these, well, I want to separate them. So I want to get this 7 in the denominator. I'm going to use my difference quotient. But I need to remember that the 2 still is going to be multiplied throughout and everything. So I'm going to have ln of 3x minus 5 to the 1/2. And because that is a quotient, I'm going to subtract the ln of 7. Okay. Then to simplify this, now I'm going to employ the power rule here, and I'm going to get 2, still there, the 1/2 of the log of 3x minus 5, okay, minus ln of 7, okay, and then I'm going to distribute my 2 to both my logs. Well, 2 times 1/2 is just 1, so I just get log of 3x minus 5. I can't simplify this anymore because I don't have a power, a rule that can separate this subtraction this way into 2 separate logs. It's just multiplication and division. So I'm just going to leave that as log of 3x minus 5 multiplied by 2 here, across there. I get minus 2 ln 7. Okay, and that is expanded form. Well, this shouldn't have changed to log. Sorry, this should still be ln there. Okay, so next one, write each expression as a single logarithm. So now we're kind of going the other way. So first I'm going to employ my power rule, and I'm going to bring these up here as powers. So I'm going to get log x to the 1/2 plus log x squared cubed. Okay, well, now with addition, I'm going to change it to multiplication to write it as a single logarithm. So it's going to be log of x to the 1/2 times, well, the rule here is it's 2, it's going to be 2 times 6, because it's going to be x to the 6th. And I can go ahead and simplify these, that when I have like bases, I am going to add my exponents. So it's going to be x to the, well, adding fractions, I need a common denominator. So 6 is equal to 12 over 2. So this is going to be 13 over 2. Okay, we could write this as log With denominator 2's is like a square root, so I can do the square root of x to the 13th power. Okay, so I've written that as a single logarithm. Now in part B, again, I like to express things as a fractional exponent on that one, and I'm going to raise all these things and put them to the power here. So I have log base 3 is going to be x to the 1/3 to the 6th power plus log base 3 y to the 4th minus log base 3 z to the 4th. Okay, so now I want to write it as a single logarithm, and things that are added are in the numerator, things that are subtracted are in my denominator. So simplify x to the 1/3 to the 6th, I multiply that together, so I get x over 6 over 3, which is x squared. This is addition here, so this is going to go in the numerator, y to the 4th. And again, these are all base 3, so that's going to stay consistent with my final answer. And then this is subtraction here, so I want to make sure that that goes and is divided here. So this is going to be z to the 4th. So that is now written as a single logarithm. Okay, last example here is we're going to be talking about something we call the change of base. So this is useful because in our calculators, when we have a log button, okay, it's equal to log base 10. We don't have a log base for every single power possible out there. In our calculators, when we have log base 10 and we type in log here, we assume that it's base 10, so we know that it's saying 10 to what power is 100? Well, that is 2. And the only other one we have is ln, and we know that, well, ln of our e to the first power is just going to be 1. And those are the only two ones that we have in our calculator. So somehow, when we're faced with a problem with log base 5 of 43, we got to be able to solve this, because 5, if we think of this as being a power, 5 to some power is equal to 43. Well, I know 5 squared is 25, and I know that 5 cubed is 125, but in between, I don't know the powers that is going to give me exactly 43, but I do know it's going to be between 2 and 3. So how can I solve this? Okay, so the first step is write this, set it up equal to x, and then rewrite it in exponential form. Okay, so after we write it in exponential form, let's take the log or ln of both sides. That is something we can use with our calculator. That's why we choose log and not some log base 5 or something like that, because we know we have log base 10 on our calculator. So now that we have taken the log of each side, we can use our power rule and drop that down in front, and we get log x times the log of 5 equals log of 43. Well, if we notice that this is multiplication here, and to get this x isolated, we can just divide out log of 5. Okay, so we have solved for x. So notice how this is related from our original problem. Log base 5 of 43 is equal to, so I always kind of think of it like this. This, the top part, is my numerator with a log base 10, and this part right here is my denominator. Okay, so this is what we call our change of base formula. So log of base b of x is equal to log of x over log of b. Or we can do ln of x over ln of b, because all it matters is that this base in the numerator is the same as the base in the denominator. And we choose base 10 or ln because that's what our calculator has. Okay, so let's look at an example here. So log base 5 of 43. Like I said, this is just going to be log of 43 over log of 5. Or I can do ln of 43 over ln of 5. So I use my calculator. I can go ahead and do log of 43 divided by log of 5, and I get something between 2 and 3 like I hypothesized before. So the answer is 2.337. Okay, I can also see if I did ln of 43 divided by ln of 5, we'll get the same answer. We know that that answer, if we do 5 to that power, that should be 43. So our answer over here is approximately equal to 2.337. Okay, that concludes our notes for today. Go ahead and highlight any questions you have and bring them to class tomorrow.